This is what it would look like at time 0. It's not moving. This is the equilibrium level right here. Okay? I'm going to shake the spring so that it has a period of 1 second. Right? So that means in 1 second, I'm going to raise it up, bring it back, down, and back. So that's 1 second, right? 1 cycle. Up, down, and back. That'll be the period. Right. So at time 0, this is what's happening, and we have a fixed end. At time equals half a second, I will have created a crest, right? Because my handle will have gone up and back to equilibrium. So after 1 second, what we have on the spring is just a crest. I'm gonna number that actually. I'm gonna call it crest number 1. Okay. At the end of the next half second, so now we will have completed a period. So now the total time will be 1 second. My crest will have done what? Not yet, right? At the end of the period, it will have moved over from here to here, right? So crest 1 is now here, and at the end of that period, I will have created trough number 1. Right? Does that make sense? So in 1 second, I went up, down, and back, and this is what's on the spring, because the wave started traveling out from me. At time equals 1.5 seconds, so now another half a period, what happened to crest number 1? It bounced off our fixed end, right? It reflected. How? As a what? As a trough, right? Because it's a fixed end, and it started going that way. So that means that at the end of the half second, crest number 1, do it in green again, is now here, but it's a trough. Trough number 1 did what? It moved over, right? Half. And so now trough number 1 is here. So trough 1 is overlapping with reflected crest 1, right? And I will have created what we'll call crest number 2, right? Because I'm starting to create another wave now. So these were the 2 original disturbances, right? This is the original energy, and now this reflects the next amount of energy I put in. Then,
Sure.
yeah.
When trough 1 and crest 1 are in the same place, would they be double the?
Not double length, double the amplitude, right? Because we have what kind of interference there?
Constructive.
Right, that's a good thing to point out there, right? This is now constructive interference, right? Because the reflected wave and the incident wave are now overlapping. At the end of the second period, so now t is 2 seconds. Let's see what's moved on. Crest 1, which has been reflected. Let me raise this up a little bit. So crest 1, which was now going that way because it reflected, is now here. Okay. So C1 is now here. Trough 1 will have hit and bounced off, right? And now it's here. So trough 1 is now here, right? Crest 2 will now be here. So now this is T1 and crest 2, and I will have created trough number 2, right? Does that make sense? And we can keep going. I'm not going to, but we can keep doing it right now. I could start creating crest and trough number 3, and they're going to match up much in the same way 1 and 2 did. And I could do 4, and I could do 5. And this energy, if there's no friction, just stays in the system, and it just keeps going back and forth. Because what's crest 1 going to do? It's going to hit here, and it's going to start going back again. Even though it's a trough, it's going to hit, and now it's going to go back as a crest. So not only is crest 2, crest 3 going to start, crest 3 is going to interlap with crest 1, which has been reversed again. And it gets complicated, but that's what's happening. And there you go. exactly what we just talked about on the board. Now, note, my hand is moving very little, but for very little movement, I'm getting a pretty substantial amount of amplitude, right? Because of the constructive interference. Now, I can change the frequency at which I vibrate my hand. Let me increase it. And I can get a different pattern. Right there. I want the one in between there. There we go. Right, now that's a different pattern than I talked about on the board, but it's the same idea. The crests and troughs are overlapping, and they're constructively interfering, and we have a lot of amplitude. Does this idea of adding bits of energy to a system and getting larger and larger amplitudes remind you of anything? So I'm adding energy to the system at a very specific interval, right, at a very specific frequency. I can only get this pattern if I go a very specific frequency. And all I have to do is put a little bit of energy in, but I get this large amplitude. Alex.
Hitting the bowling ball with the hammer at the specific intervals?
Right, when we were hitting the bowling ball with the mallet. What concept were we introducing then? Do you remember? Yeah, with R.
Resonance.
Resonance, right? So this is a form of resonance. It's just resonance on the spring. I'm adding just a little bit of energy, but I'm getting this huge amplitude. Okay? All right, so I want to go over a slide. Jeff?
This may sound weird, but like,
Remember, the point here is that it's resonance. And resonance, to create resonance, you have to match the natural frequency of the object. So I'm going to do the first standing wave pattern on the spring. Okay, that's technically resonance on the spring. I'm moving very little, but I'm getting large amplitude. That would be the first resonance frequency for the spring. Whatever my hand, I don't know whatever the frequency here is, but that many vibrations per second. Now, if I increase my hand's frequency, I lose resonance. It goes away. I don't have resonance on there. Until I get to 2 times that original frequency. So now my hand is moving with twice the frequency it was just before when I was doing this. So when I do this, that's resonance number 1, resonance frequency number 1. And now I go twice as fast, or I go with twice the frequency, and I hit resonance frequency number 2. Now, if you look at that standing wave, you see the node in the middle. Does everyone see the node in the middle? It's not moving. And then Ryan's hand is considered a node, and my hand's considered a node. Now, I know my hand's moving, but if I stop my hand moving, it still does a standing wave because the energy's trapped in there. Right? We're losing the energy, so the wave goes away. If there were no friction, we wouldn't lose the energy and it would go forever and my hand wouldn't have to move anymore. But I have to keep adding energy because of the friction. But there's a standing wave there. Again, if I stop, it still resonates at that frequency. Now, I'll keep it at the second resonance frequency, and now if I want to get to a third resonance frequency, I need to go 3 times the original frequency with my hand. Until I get that, the standing wave goes away. And there we go, right? And now we have the third resonant frequency, so the third standing wave pattern. How many nodes do you see?
2.
No? 4, right? My hand, Ryan's hand, and 2 in the middle. And how many antinodes? 3. Okay, now I want to go 4 times the original frequency. And when I get there, let's see, is that 4 or 5? I think we'll make 5. I just want to go back down to 4. Oh, no, I was tired. There was 4. I had it. There's 4. How many nodes? 6. No. 5. How many antinodes? 4. Okay. There's always going to be one more node than antinodes. The nodes are on the end and the number in the middle. So there was 5, 4 antinodes. We're going to go for...
If I send out a wave pulse, it reflects from the other end. If I send out a continuous train of waves, the reflected waves interfere with the incident waves, and we get regions of maximum displacement and regions of minimum displacement.
Does the exact same.
Yeah,
That's weird, how come it works like that without it being?
I don't know.
Maybe this fixed end stuff is made up.
Oh,
It's all
the
lies.
the laws of physics are proven wrong.
Conspiracy. Check your mind.
It definitely looks a little bit better.
Yeah.
It does, I agree. Let's see if I could just get the first pass.
Seems like I'm someone.
That looks so scattered right there.
Like the wave rider or the wave pool. Yeah.
What?